Hi friends, in this video we are going to see the given function satisfies CR equation at origin but it is not differentiable at origin. So this is the given function is square root of f of z is equal to square root of absolute value of x times y. So now we start. So what is the CR equation? Du by dx at some particular point a comma b equal to dv by dy the same particular point a comma b. Then another equation is du by dy at a comma b equal to dv by minus times dv by dx at same point a comma b. So any equation this is satisfied, we call this a CR equation satisfied. What is here u? U is real part of f, v is imaginary part of f. Next I want to write it. What is u? So u equal to square root of absolute value of xy, because whenever I take absolute value it's become past number. So u is, what is v? V is 0. They given. So first aim I want to find the partial derivative with respect to du by dx at 0 comma 0. So I have to first I want to find what is the d by dx of some u of x. So I want to define the what is the u of x is u of x defined by u of x comma 0. So whenever x comma 0 means the given function is 0 only. So u is 0. So this implies, so then I have to evaluate x equal to 0. So this implies d by dx is 0. Similarly, you have to evaluate du by dy at 0 comma 0. I take d divided by dy some function u of y. It need not be the same function, it may be different function also. Okay. So to avoid that I will take u tilde. Then you evaluate y equal to 0. What is u tilde? U tilde of y I define u of 0 comma y. Why I choose 0? Because here is the x value is 0 only, that's why. So this is also 0 only will get, correct? So the given function is d by dy of 0 at y equal to 0, we will get it as 0. So already dv is already constant function for all x comma y. So dv by dx at 0 comma 0 is 0. dv by dy at 0 comma 0 is 0. So automatically it is satisfies the CR equation. This concludes the given f of z satisfies the CR equation at z is equal to 0. Now I want to check that the given function is differentiable or not. How you check it differentiable? So this is the definition. F z is said to be differentiable if limit h tends to 0 f differentiable at some particular point, correct? Because differentiable is always a local. So limit f of z0 plus h minus f of z0 divided by h. The limit exists, that means unique exists and finite number, okay? That means the exists meaning. So that is the idea. So I want to evaluate what is the limit h tends to 0 f of z0 is, I am going to check about differentiable at origin 0 only. So z0 is 0, f of 0 plus h minus f of 0 divided by h. So what is here? H is a complex number, okay? So what is this looks like? It looks like h1 plus I times h2 will be there. So h1 is the real part of h, h2 is imaginary part of z. So this implies limit h tends to 0 square root of absolute value of h1 times h2 divided by square root of, there is no, simply you write that h1 plus I times h2 you can write, correct? Because f of 0 is 0 only, so that's why, otherwise you can write 0, no problem. Next I want to look in, now I take h2 equal to m times h1. I choose such a way that then our limit is limit h tends to 0 is become h1 tends to 0. So then this guy is become square root of m times h1 divided by 1 h1 times 1 plus m times I times m, okay? This h1 and this one. So this guy is independent of h1 right now. So we got it as square root of m divided by 1 plus im. So whenever different value of m, we'll get that different limit will exist. So f is not differentiable at z equal to 0. I hope this video you understand how to check the CR equation is satisfied, whether satisfied or not, and the function is how you say that the function is not differentiable at particular point. Thank you for watching this video.